Okay, the task today is to start Mountain. Oops. What is the task today? So last time I got to the point where the watch window was showing information, but oh dear, but it wasn't showing, it wasn't looking deeply into array structures, type defs, and I feel like pointers weren't being done either. Where's pointers? Yeah. So you see, pointers are working finely. Their names are not being set, but I can deal with that later. So here's pointers. I think structs are the most complicated ones to do. Type defs are the simplest, and arrays are somewhere in the middle. So I think I'm going to do type defs. See how far we get. And if I kind of like that, looks like a Roman numeral. Let's go with that. If I finish type defs, then I think arrays. That's going to be today, and I have longer than an hour, but I'm probably going to do at least an hour. What's going on with this? So I might not do more than an hour, it depends how far we get. So yeah, let's get started. I think the obvious way to start is to show where we are at the moment. So this is my debugger running on this Linux virtual machine. It is debugging let's get rid of this. It is debugging a sample program, which is this one. It's called Variety of Types. I'm using this one to check out the watch window because it's got lots of different types in it. There are some things missing which I think I might want to add. So one of the things that I had is there's no union here, so I think I might add a union. Let's call it union of things. Something particularly creative. Let's put an integer in there, let's put a char in there, let's... I'm going to call these by names actually. Numbers, 1, 2 and 3. Let's just have 2. So union is one thing, and enum is another thing. Enum of states. New York. State. Ouch. Main. There we go. And one final thing was a function pointer. So like this, star function, void, something like that. Let's give that a go. Does that compile? It does. This may not work now. Oh dear. That's not a happy time. So this is in binary file 1392, so I have to start things by breaking something, right? So in here we've got, we're going through, we're getting the type information, and if we got the tag and we don't have a size, then I think what I'm going to do here is quickly run this program, which dumps out the state of my test. So I've just updated it, and I'm just going to put that into this file. I think I've just discovered a few more things I need to be worrying about. So I suspect what's happening. Is there a unit in here? Let's quickly open up that file. Test fixtures, variety types.c. I'd like to know what's on decal line 7. Union. Unsigned int. Huh. Oh no, that's encoding. Wow, it's not come up with anything. Kind of surprised. Do we have something called union of things? No. Do we have something called enum? No. Do we have something called function? We do. This function does not have what? Prototyped. Type 58. Type 161. I'm not sure what all this stuff is. I don't think I've seen this before. But I think what's happening here is we've got a variable with type 161, which is pointer to 148, and 148 is a prototype subroutine type. Of 58. Returning an integer. Right, cool. So yeah, this doesn't have a size. Does it? One 61. No, it does have a byte size. So what was the complaint about? So this one, that's type 2D. Type 2D has a byte size, so it's not that. So what about this one? type 5.8, and that has a byte size as well. This one's pointed to int, type 10f. That has a size as well. I think it was that one I was looking at there. This one is type 115, which has a byte size. This one is type 6D. 6D. TD int, which is type 5.8, which has a size. Ooh, oops. The type def doesn't have a size. But we've got type def in here, so that's fine. I don't think I added any new declarations, apart from the function. 161. I'm just going to run it again onto the debugger. See why it crashed. $21. Helpful. Oh, I know it's going to be. No, it's going to be 21. Just quickly pop in here and then count elf. So that is subroutine type. 21. Yeah, so I need to check that one in as well. Right, so maybe we can show you where we are. No, we can't. What do I do now? 21. Did I get a number wrong? 16 plus 5, 21. I suppose I can refer to this. Oh, did I build? Did I build? There we go. Right. This is where we were. Great. Teach me to do things. Oh, what did I do? So, I think we want to set some breakpoints. So, we've got the watch window, very basic watch window. Some of the types here have not been resolved, which is fine. I think they know what types they are, it's just they've not been written into a name. Because there's some kind of, like the pointers, for example, I've not followed down the pointers to write the name in correctly. And the arrays as well. Yeah, so it's the type def here that's what I want to fix first. I want that to actually tell me what the value of this is. Because it used to be able to do this, but I added more stuff in since then. Okay. So type def is up here in the actual debugger code. We're just printing out type def. What we need to do is follow the chain to the real type as it suggests. So what we have is the variable type, I think. So we know we're in a type def, so we can look directly at the type def member of the union, and inside that we should have alias type, which is the server. For a start, it needs to be set to something. Way, and I can use it again. Now, kind of want to go through and check to see whether it's another alias type. I feel like pulling out this out into a function and then recursively calling it. Yeah, because the alias type that we get back might not be might not be a simple thing to resolve, but it's basically going to be one of these types again. Two interesting things. It could be it feels like this is going to recurse in the same way that the type itself was recursing. Unless so what's the input here? The input is the variable and the output is like some kind of representation of that. This is really the representation of the value of the variable as well. For a scalar, that's just like you decode it and you print it with the value, and for type def, it's going to depend on what the actual underlying base type is. So you need to follow the type def right to the end. I wonder if fall through here would be interesting. So there's two ways I'm thinking of doing this. One is to make this whole switch statement into a recursively called function. The other is kind of to take each case and make that a function that I can call. So then I can just like loop through to get the base type, which might be yet another function, get base type. it finds the base type and I pass that into like the appropriate function for, like, if it's a scalar I print out a scalar, if it's an array I print out an array. So the simple way is to do the big recursive function. Maybe I'll just try the other way. So make type equal to base type, make that equal to variable type top here, and we can be like, while base type equals, while the base type layout is a type layout, yeah, while it's a type def, just like go through and resolve it. Then base type base. Alias type. Just to make sure that's set. And as we come in here, we can just do base type. Layout, and then this is never going to be a type def. Because we already dealt with that one. Because actually I was thinking, like, oh, you have to recurse down the type for a pointer as well, but you don't, because when you're a pointer you just print out the pointer, you don't bother to recurse down. Unless you really want to show what you're pointing to in some way, which some things seem to do. So I think that should be okay. Let's have a look. This is going to be pointing. It's going to fix some of the problems, I think. Okay, that worked. So I'm really confident this is going to work, because that's what I'm running on as a debugger. Right, so I think what I want is just to pop this on here. Okay, I think this is working right. Get out to here. I want to set this to something other than 0, but it seems to be printing this out like an integer, which is good because that's what it is, even though it's actually a type def. So I think that's working good. Well, are there any other type defs in there? Maybe not. Maybe not. Let's have a quick look. So there's only one type def. But that one seems to be working, which is good news. Right, next thing. Let's call that done for now. I'm going to be optimistic and call that done. Seems to be working. Ooh, little break in the line there. So let's go on to arrays. And I'll make this test more complicated later. It's really concerning the way that renders. Let's get out of the debugger. Okay, I might check that in actually. Just going to quickly squash these two together. Or perhaps I won't. That's annoying. Maybe I will just leave it then. There's no order and that bugs me. So here, like, I'll leave it at that. Okay, so next is to do arrays. So currently we're just printing out an array, but what we'd like to do is print out, say, 10 elements. To do this, we're going to need to know the element type. So we want to print out, say, if it's 10 floats, I'm going to want to print out 10 floating point values. Well, we could start with just by printing them out in hex, maybe. For that, we'll need to know their size. Now, all types have a size, but I don't think I've backset all ones that don't actually have a size. So they're just going to be 0. Everything I'm doing is making me think, this would be so much easier if you just gave in and recursed here. Like this one was simple, but here what I want to do is essentially, like, say it's an array of arrays, then that's fine because that'll be a pointer. That's an interesting point. It's an array of some kind of scalar, so I want it to do all this stuff. I don't have to write that out again. So it might be the case. Like I could do something outside this switch, which said go find the base type of element in the array. Which would follow through the type defs. And I need to remember that I wanted to do that 10 times or something. And then the struct would be similar. So the leaf things that we can print out are pointer and scalar. Struct an array are not leaves, so maybe they should be dealt with beforehand. That's one way to do it, right? We only ever want to go one level deep, so it feels like recursing isn't strictly necessary. But what is necessary is to kind of check up here. Get to our base type. I thought by crushing all of the type defs, then we say deal with arrays. So like if base type layout equals base type layout array. And we're going to want to get the array dimension, which will be our base type. No, it's not going to be a base type, it's going to be a variable type. No, it is going to be a base type. Oh, yeah. My brain trying to work and think. An array. An array has dimension. It also has an element type. We simply want to go through the array. It's not a dimension, it's element count, isn't it? I feel like dimension might be the wrong word here. Maybe it's okay though. So you'd go through and you'll be like, for each of these, I'd want to be actually elements elements to display is like max minimum 10 and dimension. And each time down the loop you would get a value pointer. Right. I'm going recursive, I think. So if we call format variable value on the memory buffer, we put pass in the value buffer, buffer. Your result, this is where our thing is, and then we'll need the type as well, which is going to be there. So I think what we want here is just to do format variable type. It's a new function I'm going to write in a second. Put in our value buffer. Put in our memory buffer. I don't think this is right anymore. It's memory size and bytes. It could be 0 for some things, especially if you're looking to it typed just so. I'm not sure if that the value for Intel was giving was correct. I'll check that in a minute. Let's do something different. So here we just want variable type. Maybe this read memory needs to go in here as well. Then we make this a internal hide format variable type, and then we've got U8 star debug type star type. And we've got the result buffer, I think it's a char star out. Yeah. Going to need to know the size of the out buffer as well. Right. The first thing we're going to do is say switch type layout. Right. Then we can do case layout. Layout is a type def, then we're in this case here. So this is just the pass through. Here we can just assert type. Although yes, the reference is going to fail anyway, so it's pointless. Okay. So that would do this piece here. Recursively. And we could be like, okay, so case type layout is an array. Then we can do this. be right back. 1 minute. Okay. Much stroking of beard going on here, because I'm wondering about how we advance, how I advance this out pointer. Thinking maybe this function should return how many bytes it's written, which might be a solution here. Work. So like that, we need to pass in a char star star. Pass an offset. Maybe we do it that way. And we have like a bytes written. Right, sorry about that. Yeah, so I think if we return back how many bytes we've written. And we just like tot up all the ones that have been written by any child calls, then we should be good. Is that going to work? This is the case where I care, right? Because I want to add in because I want to offset this. Okay, that seems fine. And then go that. Pop this one in as is. So the problem here is that smprintf writes out, returns back essentially the length of this, not the how many bytes it actually wrote out, if I recall correctly. Let's just check that.